Here we have Damian Brunner, who is a senior R&D manager, solar and battery at leading wet chemical solution supplier, RENA. Damian is going to give an overview of wet chemical solutions for N-type cell processing. Damian, the floor is yours.
Hello, Swaran, and hello, everybody. Thank you for the kind introduction and an invitation for share our results here. I hope you can see the screen well and hear me well.
The screen sharing, not yet, but we can see and hear you.
Okay, let me double check with the screen sharing. Just see. Okay, can you see the screen now?
Yeah, we see your full screen.
Now?
Yeah.
Okay, perfect. Thank you for your support, Trevor. Okay, now let's go ahead. So the title of our presentation is, we want to share an overview of different solutions for wet chemical processing of N-type solar cells. A quick slide for introduction of RENA. We were founded 30 years ago. Our headquarters is located in South Germany, in Gütenbach, in the Black Forest. We are about 1,200 employees, have a annual turnover of about $250 million, and installed base of more than 3,000 machines, of which more than 2,000 are for PV and mainly installed in China, with 2 decades of experience in PV, let's say. And we consider ourselves as one of the technology leaders for wet chemical processing and especially for PV. So I'd like to start our presentation by giving you an overview for motivation, how wet chemistry is impacted and located in the whole process chain, starting from poly making up to IV measurement, and look on the performance and OpEx roughly. So after poly making, as you all know, with a general view, ingot pulling and diamond wire sawing is taking place, and then followed after several handling steps by the first 2 wet chemical process steps. So first pre-cleaning and degluing, and while keeping the wafers wet, then during separation, a final cleaning step and drying takes place with the second wet chemical sheet. Those wafers are then placed into the 3 most promising cell process flows. Let's have a quick generalized look on it. For the major route for TOPCon, the first step is wet chemical texturing and with a customized additive. After diffusion, the second wet chemical step takes place for edge isolation with a cluster process of inline and a batch tool. After poly layer deposition and annealing, third wet chemical step takes place by poly wraparound removal, again with a cluster, preferred with a cluster configuration inline and batch, and then firing, metallization firing, IV measurement. Heat reduction, similar. The texturing is the first step. Here we prefer to have a customized additive, or this is our offer to the market. And after the position of the active layers, amorphous silicon, TCO, metallization, curing, IV measurement. So there's only just one, but a key texture, wet chemical step. And for IBC, there are many different approaches. This is just one simplified, rather pessimistic from the wet chemical point of view process flow. So after texturing, again with a customized additive preferably, at some step a rear side polishing is necessary, and in general speaking, local deposition and annealing of passivation layers or TOPCon layers. Then passivation front and rear laser structuring is typically needed, and of course metallization and firing. all of this process flows are aiming for, let's call it the holy grail at some point, the perovskite to be compatible to perovskite tandem. And there most likely a feedback loop will appear with new demands for texturing in the future. So overall, we see at least 3 up to 5 for IBC, maybe even some more process steps for the whole value chain, and there's a strong impact of wet chemistry. And we also begin more and more to experience a strong interplay, for example, between wafer quality processing and texturing, and between texturing and the final clean and passivation. There is definitely some room for efficiency gain and cost reduction if you have a picture over all steps and try to optimize the interplay. So with all this, there is a big impact from the wet chemistry side on water chemistry, energy consumption, and of course on the yield and the overall performance, self-speakingly. So with this, I'd like to come to the overview of the presentation we have prepared for you today. So we will look on all the topics. Main focus is, of course, TOPCon. And first, we start with wafering, heat rejunction, IBC, and perovskite cells. So for solar wafering, as mentioned, our solutions we would like to bring back. We used to offer these solutions until 2015, and after a pause, now we try to bring back the processes in the RENA portfolio. And as mentioned, first step is the pre-cleaning and degluing, and after separation, the final clean will take place with the throughput for the final clean up to 15,000 wafers per hour, and for the pre-clean of 8 bricks per hour, which is round about 2.5 gigawatt. To demonstrate that these processes are on a very good level, so comparable to the competitors, you can see images of final clean, cut and clean wafers from a Chinese reference, typical market wafers after SDR and after texturing. And here you see our solutions on a very optically on the same level. If we look more into detail after texturing and measure the reflectivity, here in red the reference value, and some groups we optimized are at least on the same level. So with this, let's have a close look on TOPCon, the major topic of this session today and of this presentation. So here we want to look on all wet chemical steps in some more detail. So let's start with texturing. For texturing, we offer our BatchTex 3N600 tool, which has a length of about 25 meters, can carry up to 6 carriers per bath with 120 wafers per carrier. The process can be run with or without SDR, and all the cleaning and oxidation steps are per default. Suggestion and recommendation from RENA is to use ozone steps due to reduction of running cost while keeping the same performance as if other chemicals are applied for this process step. And depending, of course, on wafer size and carrier density chosen by the customer, throughput of up to 1.3 gigawatt can be guaranteed with this platform for texturing. So having a closer look on performance, here we can offer a new generation of additive for PERC typical reflectivity values. We obtained above 11% in reflectivity. With this new generation of additive, we can come down close to 9%. And the tricky part is now to transfer this new texture into a working solar cell device. This has been successfully demonstrated together with Fraunhofer ISE last year with efficiencies up to 23.8%. And we consider this as a first proof of principle that customized texturing for TOPCon can show benefits For future, we aim for reflectivities below 9%, and we also have this latest version demonstrated at some customers of ours with efficiency surpassing 25% in production. To quickly summarize some other performance parameters for this new additives, of course, as shown, we can show you, guarantee you a higher JSC. Increase in throughput is another advantage. Also, some energy savings since the process is run at a lower temperature, and maybe most significantly, or also a significant advantage is to reduction of KOH concentrations, thus reduce chemical costs, running costs. This, I like to come to the second topic in TOPCon, solar cell wet chemical processing, the edge isolation. Here, as mentioned at the beginning, we follow the mainstream approach with a cluster combination, inline processing for single-site glass layer removal, for the BSG removal, with 12, very shortly up to 14 lanes in an inline simultaneous lanes, with a throughput very well matching this batch tool, also in the range of 1 gigawatt per hour, length similar to the texturing, and the sequence is of course adapted compared to the texturing. The performance demonstration we can see here on this slide. Lately, we optimized this process. We had a closer look in our last experiment on the edge isolation. Here, a very fast process and a reasonably fast, so it's called medium here, this process B. And if we run too fast, of course, this has an impact on the JREF2. This can be increased. But for our optimized process, the process B, we have very low JREF2 values, so good junction isolation, while combined with a good efficiency performance with values up to 24.1%. With this, I'd like to come to the last subchapter for the TOPCon section of our presentation. Here, as mentioned before from Laplace, the goal of the poly wraparound edge is to remove all the residual poly at the edges and the wraparound and on the front side of the solar cell. So depending on the deposition technique, on the loading technique, either it's PCVD, LPCVD, single loading, double loading, we have different configurations. For double loading, also a BSG can be present here, and we managed to adapt our process that this, for the cluster solution, this can result in such a shape of the wafer after poly wraparound removal. So as mentioned, we have this, again, this combination of an inline tool and a batch tool, also for the poly wraparound removal. And of course, the sequence in the batch tool is adapted for this process. Main task, as shown 2 slides before, is to remove all the wraparound and the indiffusion at the edges. So the main parameter, there is no gain in efficiency we can obtain here, but we can guarantee a very low value of the JREF2 to be able to produce long-term stable modules. And here on the x-axis, we have the etching time. So if we optimize our process for the poly wraparound removal, we can guarantee very good values for the JREF2 below the threshold of 2 milliamp per square centimeter. And another characterization is that this glowing of the edges here can be eliminated completely after adaptation of the process. We also offer inline solutions here. This has the advantage that no additive is needed. And here also very low JREF2 values can be obtained, and the edges look just perfect as well. This, just very quickly, let's have a look on silicon heterojunction. Here, our main product is the batch texturing tool, and our innovation here in the recent month is a new customized additive for heterojunction. So this Monotex 2.7 is the same as for TOPCon, which is already showing some advantages compared to reference texturing additives as well from our side. Also, this was, as I have to mention, those results were obtained in collaboration with CA Ines, and also the reference additive from them performed on this level. So this new generation show a nice efficiency gain for the TOPCon additive, and for heterojunction customized additive, we can even show efficiency gains up to 0.4% with a champion efficiency close to 24.5%. For IBC and perovskite solar cells, this would be our next topic. For IBC, we can again offer improved performance of the front side in the texturing process step. Here we have some additives which are not suitable for heterojunction or TOPCon, but for IBC, maybe with a more independently adaptation of the passivation scheme. Here we can offer a fine-tuning of the reflectivity down to 7%, depending on the composition of the additive and processing features. So our idea is to team up with partners and evolutionary bring down the reflectivity and adapt the passivation step by step. IBC. And last topic here before I come to the summary is the perovskite. Here, as mentioned by Angelika Harter at the EU PVSec in Lisbon this year, there is a strong trend in the perovskite community going from bigger random pyramids to very dense and small distributed nanotextures. And here we can offer our latest version with some adaptations. So shown here is the pyramid count over pyramid height. In blue, our old distribution. In red, our latest version. And if we apply further pre-treatment of the surface, we can achieve distributions, very tight distribution with a peak around 0.5 microns. So well in the nano region. This I come to the conclusion, and we have 4 take-home messages. That wet chemistry is one of the key technologies for PV, and especially for TOPCon, maybe even for IBC in future as well. RENA can offer several solutions for reduction of running costs and saving resources, water, energy, chemical, and increase of efficiency. We are aiming for and are very close to be a one-stop solution for all wet chemical processes in solar, and most of our products and processes we offer are demonstrated to perform on very high efficiency levels, surpassing 24 or 25%. With this, I'd like to thank you very much for your attention.